Hey guys, welcome back to the second part of our chatbot tutorial. So in this part, we are going to create the actual training data. So we already created the NLTK utils to tokenize and to stem our words. So let's continue and apply this to our data that we have. So we will create a new file and let's call this train.py. And here we want to load our JSON file. So we need JSON, the JSON module, and then we can say with open, and then it's called intents.json in write mode, or no, read mode, sorry, as f. We want to say our intents equals JSON.load f, and then we can print our intents. So let's clear this and let's run the training file to see if we have this loaded. So this is working. And then we want to create our training data, as I showed you in the first part. So we want to apply tokenization, then lowering and stemming. Then we also exclude the punctuation characters, and then we apply the bag of words. And for this, we need to collect all of the words. So let's do this. So let's create empty arrays first, or empty lists. So we say all words equals an empty list. And we also want to collect all the different patterns and also know which different tags they have. So we create an empty list for the tags, and we also create an empty list which we call xy, which will later hold both our patterns and then the tags. So now we want to loop over our intents. So we say for intent in intents. And this is, as we can see, a JSON, or now it's a dictionary, a Python object. And in the very beginning, we have the intents key, and then we only have one array with all the different tags and patterns and responses. So we say for intent in intents with the key intents, and then we get the tag by saying this is intent dot, or with the key tag as in the JSON file, so the tag key. And we will append this to our tags array. So we say tags.append our tag. And then we want to loop over all the different patterns. So this again is an array with the different patterns. So we loop over this. So we say for pattern in intents with the key patterns, and then we have this pattern, and then we want to apply tokenization. So we already implemented a utility function in the last part, so we simply have to import this. So we say from NLTK utils import tokenize, and let's already import the stemming function and the bag of words function. So now what we want to do is we want to tokenize our patterns. So we say w equals tokenize the pattern. Then we want to put this into the all words array. So we say all words, and then dot extend and then W. So we are not using append but extend, because this again is an array and we don't want to put an array of arrays here, so we want to extend this here. And then we will also put in the pattern or the tokenized pattern and the corresponding label to our XY list. So we say XY append, and then here as a tuple, we use W and the tag. So this will then know the pattern and the corresponding tag. And then we are done with collecting these. So now if we go back in our pipeline, after tokenization, we also want to lower and stem the words and exclude punctuation characters. So let's do this. So let's define some ignore words equals, and then here, for example, we don't want a question mark or a exclamation mark or a dot, or let's also don't use a comma. And then we apply list comprehension. So let's simply print all words to see if this is working. So now if I clear this and then run this, then we see we still have an error here. So for pattern in intents on, oh yeah, so now we only have to use intent, so for each single intent and then the pattern. So let's run this again. And then we see we get all the different words, so they have been tokenized. And now let's apply stemming. So let's say our all words equals again a list, and then we stem each word for W in all words. And we also want to exclude the ignore words, so we can very easily do this with list comprehension too. So we say if W not in ignore words. And now let's clear this and run this again to see if this is working. So I still have this from the last part, so we don't need this anymore. So now here we see we have all the words in lower cases, and for example here we see that the ending got chopped off, so stemming works too. And now let's sort these words. So let's say all words equals sorted, and then we also only want unique words, so we can simply convert this to a set. So this is a nice little trick to remove duplicate elements. And then the sorted function will return a list again. So now let's do this with the tags too. So let's say our tags equals sorted and then a set from the tags. So now this will have unique labels. I don't think that this is necessary, but it's better to do it. So let's print the tags here to see if this is working. So let's run this. And then we see we have all the different tags. So delivery, funny, goodbye, greeting, items, payments, and thanks. So now what we want to do is to create the training data. So for this, we want to continue in our pipeline and now create the bag of words. So let's create a list with our X-train data. So let's say this is an empty list, and then the Y-train equals an empty list. So this will be the tags or the associated number for each tag. And in the X, we put all the bag of words. So we will loop over our X, Y array that we have here. So we say for, and then we can unpack this tuple here. So we put a tuple here with the pattern and the tag. So we say for pattern, or let's call this pattern sentence, and tag in X, Y. And now what we want to do is we want to create a bag of words by calling the function bag of words. And we can see we already implemented the definition. So this will get the tokenized sentence. So this is exactly the pattern sentence, which is already tokenized. So here we apply tokenization, and then it needs the all words. And then we append this to our training data. So xtrain append the bag. So we still have to implement this function then. And for the y data, so this will be our labels. So for this, we use the tags and then tags.index tag. So for example, did we print the delivery? Did we print the tags? Yes. Here we still have the tags. And now if the tags are in this order and we have the tag delivery, then this will give us the label 0, and for funny, this will give us the label 1, and so on. So we have numbers for our labels, and then we put this to our Y train. So Y train append label. So here we have to be careful. Sometimes you also want this as a so-called one hot encoded vector. But in this case, we are using PyTorch, and later we are going to use the cross entropy loss. And this doesn't want it as one hot. So here we only want to have the class labels. So it's called cross entropy loss, which we will see in the third part. So that's why we don't have to care about one hot encoding here. So only put in the label for this pattern. And then after this, we want to convert this to a NumPy array. So we import NumPy as NP. And then we say our X train equals a NumPy array based on this X train list, and the same with Y train equals NumPy array Y train. So now we have the training data, and now we still have to implement the bag of words function. So we didn't do this in the last part. So let's do this now. So here let me copy and paste an example for you again. So now what we have to do is we have our tokenized sentence with our new incoming word. So hello, how are you? And then we have the all words. So here we already collected all the words based on the patterns that we looked up here. So this is just a small example. And then we look at each word in the sentence, And if it is available in the words array, then we put a 1 here. So for example, we have a hello. So we put a 1 at the position where hello is. We also have you here. So we put a 1 at the position where you is. And we don't have are. And we don't have how in this example. So all the rest of the positions will be 0. So this is how the bag of words is working. So now let's do this. So this will get a tokenized sentence. And in the training pipeline, we will also apply the stemming for the all words array. So let's do the same for the tokenized sentence. So let's do this, and let me close this here. So now we want to call the stemmer for each word in the tokenized sentence. So we use list comprehension again and say tokenized sentence equals the stemming function of our word W for W in tokenized sentence. So now we applied the stemming, and then we create a bag and initialize it with 0 for each word. So like this, we have all words, and then we create an array with the same size but only with 0. So we can do this with NumPy. So we need NumPy here too. So import NumPy as NP, and then we say our bag equals, and then we say NumPy zeros with the size of the length of the words, or it's called all words here. And then let's also define a data type. This should be NumPy float 32. And then we loop over our all words. So we say for index and word enumerate all words. So this will give us both the index and the current word. And then we check if this word is in our tokenized sentence. So then it will get a 1. So we will say bag with this index equals to 1 as a float. And then we will return the bag. So let's try this out. So let's say our sentence equals this one. So this is already tokenized. Then our all words are these words. And then our bag of words equals the bag of words function with the sentence first and the words first and the words second. And then we print the bag of words. And now let's clear this and run Python NLTK utils. And then we see we get the same array as I showed you here. So this is working. So let's remove this again. And then we are done with this file. So let's head back to our training file. And now, as a last thing in this part, I want to create a PyTorch dataset from this training data. So let's import some things that we need for PyTorch. So we import torch, we import torch.nn as nn, and we say from torch.utils.data we import data set and data loader. So if you haven't installed PyTorch already and don't know what these are, then please have a look at my beginner course, because there I will explain all of these things. So now down here, let's create a new data set. So we have to create a class and call this chat data set, and then this must inherit data set, and we have to implement the init function, which will only get self, and here we will store self dot number of samples equals, this is the length of X train. Then we will store the data, so we say self.xData equals just our xtrain array, and self.ydata equals our y training array. And then we also have to implement the getItem function with self and the index. And here, so this is that we can later access data set with an index. And then we can say, here we return self.xData of this index and self.ydata of this index as a tuple. And then we also define the length method with self. And here we simply return self.number of samples. So now we have our chat data set. So let's create this. So let's say data set equals chat data set. And then we also want to create a data loader from this. So we say our train loader equals data loader, and then as a data set it gets this data set. Then we say batch size equals batch size. So let's create or define some hyperparameters here. So I have to put this here. So let's say hyperparameters, and then here we say batch size equals, let's say 8 in this example. And then we use this here. We also say shuffle equals true for our training. And in my case, I say number of workers equals 2. So this is just for multi-threading or multi-processing. You also, or on Windows especially, I think this might raise an error. So let's try to set this to 2 in your case if you get an error here. In my case, I'm using 2. This makes the loading a little bit faster. And yeah, so now we have our chat data set. So why did I implement this as a PyTorch dataset now and created a data loader? And this is just because then we can automatically iterate over this and get batch training. So that's it for part 2. And then in part 3, we will implement the actual PyTorch model and the training loop. So see you next time.